Alright, today we're solving search insert position. This is a pretty classic challenge where we have a sorted array of distinct numbers and our job is to find the index of the target or return the index where the target should be if it were inserted in order. This involves utilizing binary search in order to get a big O of log n time complexity and constant space complexity. Here we have example 2 from Leetcode with a target of 2. We'll start by initializing a left pointer with a value of 0 and a right pointer with the last index of our nums array, which is 3. The general idea of binary search is we essentially eliminate half of the input from consideration each iteration. So we'll set up a while loop that will run while the left pointer is less than or equal to the right pointer. We'll calculate the midpoint by adding the left pointer and right pointer together and dividing that sum by 2. Then we'll pass that product to the math_for method. This gives us a starting midpoint of 1. We check if the target equals the value at the midpoint, which is 3. It does not. Our target of 2 is less than our midpoint value of 3, so the else if evaluates to true, and we reassign the right pointer with a value of the midpoint minus 1, which is 0. We do minus 1 because we already know from our first if condition that the value at the current midpoint is not our target, so we can eliminate that from consideration. The while loop iterates, and now we have a midpoint of 0 and a midpoint value of 1. 1 does not equal our target of 2. The target is not less than our current value of 1. So we reach our else statement and we reassign the left pointer with a value that is the midpoint plus 1, which gives us a left pointer of 1. Our while loop condition evaluates to false because a left pointer of 1 is greater than a right pointer of 0. So we exit the while loop and return our left pointer of 1. In other words, our target of 2 should be inserted at the first index to maintain the correct order. Let's translate this to code. Okay, we'll start by setting up a left pointer with a value of 0. We'll set up a right pointer to be the last index of our nums array. We'll set up a while loop that will run while the left pointer is less than or equal to our right pointer. Inside of our while loop, we'll store the midpoint in a variable. For our if condition, we're going to check if the target is equal to the value at the midpoint. If it is, we're just going to return the midpoint. Else if the target is less than the value at the midpoint, we're going to reassign the right pointer to be the midpoint minus 1. Else, that means the target is greater than our midpoint value, so we're going to reassign the left pointer to be the midpoint plus 1. And if we make it out of the while loop without returning the midpoint, we're going to return the left pointer, because that means our target wasn't present in our nums array, and the left pointer is where we should insert the target. If you found this video helpful so far, please take a moment to hit the like button. Okay, let's save this and run it against our test cases. And we get the expected output. Let's copy and paste this solution into Leetcode. Okay, let's paste it in here, hit submit, and we get an accepted solution. Thank you for watching.